Hi everyone, welcome to another Stationeers tutorial. Today, this time I'm going to tackle dual axis solar tracking. Okay, so with the vertical, we have the daylight sensor pointing this way. If you watch the single axis tutorial, you should understand how that works. Understanding dual axis, you have to understand these sensors. There's no other way to do it. So when this sensor is pointing at the horizon, when the sun rises, that's an angle of 0. Now assume you have an angle of the sun going directly overhead. It's not going to do that. I'm on Vulcan right now, but on Venus it goes directly overhead. So when the sun rises, you have an angle of 0. And then when it's vertical directly above you, the angle's 90. And then when it's directly behind the sensor, the angle's 180. And then when it goes down below the horizon, it starts to count down again, 170, 180, 60, 150, 140, 130, and so on, until you get to 90, and then back to 0 again. So it goes 0, 90, 180, back to 90, and then back to 0 again. So as you can see, we're getting there. This thing will say nearly 0, so 16, okay, 15. It's counting down. When it gets to 0, that thing will have been officially risen. Okay, now when you're doing horizontal tracking, I'm going to just pause it because I don't want to waste the daylight. I want to get all this tutorial done while the sun is out so you can see what's happening. To understand solar tracking, you really have to understand these daylight sensors. Now, horizontal tracking is much easier to do if the sensors are on the ground like this. Okay, and they go from 180 degrees. So when the sun rises, that'll give us a horizontal of 0 on this one. And it'll be 90 on this one, negative 90 on this one. It'll be 180 on this one, and it should be 90 on this one. And it's actually quite fortunate. Let me just repair these. I had just had a storm just as I was about to start this tutorial. Okay, so let's look at the actual solar panels. The actual rotation goes negative, so it's actually fine. We can just take the reading directly from one of these four things and feed it into the solar panel, and it'll horizontally track properly. Now, horizontal tracking is actually a pretty good approximation. If the vertical stuff is going to take too long to set up, or you're too rushed for time, just setting only horizontal is perfectly fine. Well, it'll give you a bit more juice than trying to do vertical. This black hole is going to go across the sky like that. Go from there, from here, it's going to go across the sky, maybe get as high as 30 degrees. Obviously, vertical tracking is useless. We want horizontal tracking at the very least. Now we have to choose which one of these sensors we want. This is actually the one we want because the horizontal angle was 0 when the sun rose. But it does depend. That's because of the way I've arranged my solar panels. The horizontal here is 0, you can see. Horizontal is 0. If I had these data ports a different way, if I flip the power and the data around, if I do a complete 180 on this solar panel, I'll probably want to use this one, because this one will read 0 when the sun, because my 0 arrangement will be with the solar panel pointing the other way, and I want this thing, I want to use this one. So which arrangement of I'll just get them centered, which way these are pointing is very important, and the one you want to use depends on how you arrange your solar panels. So I've got my solar panels currently set on 0 horizontal when the sun rises, and you can always tell that if you make the vertical down to 0, if you notch this thing down to 0, it should point directly at sunrise. Okay, so of these 4 arrangements, this is definitely the one I want, because my solar panels say 0 at sunrise, and this horizontal says 0 at sunrise. I hope you're all following me so far. Okay, so I'm going to just drill that one up. We're going to use this one. If we try to use this arrangement where it's vertically placed, it's a little bit harder. It's going to require some tricky math. This way we don't need any math at all. We can just feed the value right in. Now let's get some horizontal tracking going. I've already set up these. I've named this logic reader horizontal, and I've named this batch writer horizontal. Don't worry about all the cabling on the ground. I put it in place beforehand to save time. Generally, you put down the writers and readers and all the stuff first, and then you cable them up afterwards and just basically connect all the holes. I've just done it beforehand to make the tutorial a little quicker rather than you guys sitting there watching me place cables, which would be ridiculous. Now, to set up horizontal tracking, it is incredibly easy. I've got them upside down, but that's to make the spacing easier a bit later on. It doesn't really matter. I want the device to be my daylight sensor. This is the only one connected to the network, and I want the variable to be horizontal. I can go and turn that on. And on the batch writer, I want the device to be the logic reader horizontal. I want the output to be the solar panels, and I want the variable to be horizontal. Okay, now if I turn this on, these guys are just going to follow the sun. Now, if you're in a rush, you don't have time to set up vertical, you can just, basically tilt these, take a guess. Basically, you might say 15 degrees. Maybe if you're on Mimas, you might use 15 degrees. On Vulcan here, 20 works pretty well. You might just decide, okay, I'm just going to leave it like that. And these things are just going to track the sun all the way through. The reason is this is giving me a horizontal angle of 30 degrees. And if I look at this, the horizontal, 31 degrees. So, it's changed 1 degree since then. You can just feed the value from this into these. And to do that, you first read the device with the logic reader and you write it to the solar panel you send the information from the reader to the batch writer, and the batch writer sends it to all the solar panels. Okay, so hopefully that's very, very straightforward. I hope everyone understands that. Now, this is where it gets tricky, the vertical aspect. You don't want to sit there manually adjusting them. You can't on Vulcan anyway. You'll get too hot, use too much oxygen, burn up, whatever. We want to make it fully automated. Now, this is where reading these things is important, and we're going to use this one to read from. Now, let's look at the vertical angle very quick. I'm trying not to waste daylight here. That's why I keep pausing it. I'm sorry about that. The vertical angle is 61 degrees. Now, we've got to understand what that angle means. Now, if you face this towards sunrise like this, okay, the vertical angle is basically the angle the sun is, or black hole, is from the, okay, I need to explain something else first. Okay, remember, this thing here, pointing straight out is 0. For this thing here, pointing straight up is 0. So straight line, straight up into the sky, that's our 0 degree angle. When it reads the vertical, what it's doing is it's taking it from the 0. So from straight up to our star, the sun, the black hole, whatever, I'm going to say the sun from now on. Our angle from straight up to the star is that angle that's given there. So there that says, what does it say? 58 degrees. So from straight up to that star is 58 degrees. Now this is important. We can't just convert that into a percentage and stick it in our solar panels, because we're not doing a angle from the horizontal up, and that's what our solar panels want. We want an angle from here to there. What we're doing is we've been giving an angle from straight up to there, and that angle currently is 57 degrees. I hope everyone follows me. If you wanted to know what the angle was from the flat, from the horizon up, we're going to have to take that number from 90 degrees, because it's 90 degrees from here straight up. So that angle is currently 56 degrees. 90 take 56. That is something, 34. So we actually want our solar panels, we don't want them yet, but 34 degrees is the angle from the horizontal to the star, to the sun or the black hole, to the whatever. 34 degrees. Now, we could just convert that into a percentage, divide it by 1.8, and we have some approximate solar tracking, but we can do much better than that. Remember, our solar panels don't count the first 15 degrees, and they don't count the last 15 degrees. Their full lock 0% is a 15 degree angle. Okay, we don't want the first 15, we don't want the last 15. Okay, we want everything in between. Okay, so 180 degrees, take away 15, take away another 15 is 150 degrees. We have a 150 degree arc that our solar panels can possibly take. And that's it. That's 0% to 100%. Okay, so to convert a 150 degree angle, an angle out of 150 degrees to a percentage, you would need to divide by 150, then times by 100, which is the same as dividing by 1.5. We don't have to have logic maths all over the place. We can shortcut that, because one's a times, one's a divide. So just divide by 1.5. Now we don't want to count the first 15. Okay, so this is where it gets tricky. Let's think about this vertical reading. When the sun rose, it was 90-degree angle because it was perfectly perpendicular to straight up. Remember, straight up is 0. Straight up is 0. And 90 degrees, when it rose, it was hitting 90. That is 0. Okay, and now this angle here that it's giving, 52 degrees, that is the angle from our reader to the sun. Okay, now once again, remember, we do 90 take 52. That is 38. So that is 38 degrees off the horizon. But we don't want off the horizon. We want off 15 degrees from the horizon. So what we really want to convert, the angle we really want to convert is not 38 degrees. We want 38 take 15, which is 33, 23, right? 38, 15, 23. Yes. So a 23-degree angle. So from 15 to the sun is 23 degrees. And what we want to do is take that angle and divide it by 1.5. Just like when we did in single axis, when we divide by 1.5 to convert it into a percentage, that's what we're doing. But we don't want to do the full 38. We want to do 38 minus 15. Now, let's think about the calculation we're actually doing right now. We're doing 90 degrees, take away this reading here, take away 15. Now we can do all that in one step. Whether you take the 15 second or take the 15 first, it doesn't make any difference. 90 take 15 is 75. So what we really want to do is 75 take this angle. It's like saying 5 take 2 take 1 is equal to 2. But that's exactly the same as 5 take 1 take 2, which is also equal to 2. So we're going to do, instead of 90 take the angle take 15, we're just going to do 90 take 15 take the angle. And we can do the 90 take 15 in one hit. That's always going to be 75. Okay, so we want to do 75 take away this angle to give us what we want for the solar panel. I hope that makes sense to people. Now, when the star or sun or whatever passes the midway point, right, let's think what's going to happen to this angle here. This is 0. Straight at the horizon is 90. Back this way is 90. Remember, it goes 90, 0, 90, then down below the Earth is 180, then back to 90 again. And that's what it's going to do. So when it hits the midway point, that angle, we're going to want to do the exact same thing. The angle this gives is always going to be the angle to the star from 0. So whether the star is there, starting its journey, or way out here, it's going to be the exact same calculation to figure out what percentage we want the solar panels to be at, what angle we want the solar panels to be at. It's going to be 90, take the angle, take 15. Remember, we don't want these things flipping all the way over like in vertical tracking. We just want these solar panels to go up to where they need to be and then come back down again. We don't need to flip all the way around because it's going to be horizontally tracking the whole way as it goes. So just the simple calculation of 75 take the angle will give us the angle we need. And then we just have to convert that angle into a percentage, which is easy, divide by 1.5. I hope everyone understands that. You might have to go over it again and maybe write the numbers down on a page so you can follow what I mean. But yeah, so the angle of this is the angle from 0. That's 0. That angle there, from 0, from there to there, is the angle that this is giving. And it's currently giving an angle of 49 degrees. Okay, so what we want to do, we want to keep the horizontal in place. This is actually great. The horizontal, we want it to track as it is. What we're going to need is some input outputs. We're going to need another logic reader, this time to handle the vertical. And we're going to need another batch writer, this time to handle the vertical as well. And let's go and rename these so we can find them easy. Logic reader vertical, confirm. And then batch writer vertical, confirm. Okay, and the calculation, we know what the calculation is going to be. We're going to want to take the angle from 75, and then whatever reading we get, we're going to want to divide it by 1.5. So the two fixed values we need a 75 and a 1.5. So we need two logic memories, one for the 75 because that's a fixed value, and one for 1.5. And we're just going to rename these. I'm going to do this as quickly as I can. I want the sun to be up when I do this. logic reader 75. Now we have to actually set it to 75. There we go. And now we're going to go logic memory 1.5, and we want to then set it to 1.5. So these are values that are fixed, 1.5. There we go. Now we're going to want a math unit. We're going to 2 math units, one to subtract the angle from 75 and then one to divide whatever we get by 1.5. So that's these logic processes here. We chuck one here, logic math, that's perfect. Another logic math, that's perfect. This is going to be our subtraction. So we'll just call it a logic math subtract. And this is going to be our division. This is going to be logic math, we'll just call it logic math, divide, because we're doing the divide operation. Okay, so we've got all the chips we need. Now we just have to set them. Okay, so you already know how to set the horizontal, because that was the first thing I did. Now let's go to the vertical. We want the daylight sensor to get us an amount. So daylight sensor, whoops, went too far. And the variable is going to be the vertical. So we want to read the vertical off the daylight sensor. We can go and turn that on. Now we want 75 subtract the angle. So we want the logic memory 75, and we want to subtract whatever vertical reading, the logic reader vertical. So this thing is being read by this, which is giving us that, and we can go and turn that on. Now we want to take the information from this. This is called logic math subtract, this chip. So we want to go logic math subtract. Here, that's the name of that chip there. So whatever reading that says is going to go into here. Then we just want to divide it by 1.5, which will, did I put the, divide by, and we're looking for logic memory 1.5. Okay, I hope everyone's following me so far. What we've done is we've figured out the vertical angle that we want the solar panels to point at, and now we're dividing by 1.5 to convert that into a percentage. Because an angle out of 150 doesn't help us. We want a percentage out of 100. We want an amount out of 100. So divide by 150 times by 100. That's the same as dividing by 1.5. Okay. And now on the in, we want this to be the So whatever we got from here, the logic math divide, we want this to be fed into here. So logic math divide. We want the output to be the solar panels, if I can find them quickly in time. Yep. And we want the output variable to be vertical. And now, if everything's right, we can just turn all these things on. And these things should give us perfect solar tracking. The sun's low. This one's blocking this one, but we can look at this one. 99%. There we go. Fantastic. It's giving a fantastic amount of power. And this is just going to track the sun perfectly from now on. This one's blocked by that one. The reason it's 99 and not 100 is because my CPU is a little on the old side and there's a delay in processing. If you want to get rid of that delay, you can change this this memory so that instead of 75, you could maybe make it 74.9, or you have to experiment a little bit with it. So we can make that 74.6 for instance. And maybe that'll be a bit better. There we go, 100% efficiency. Yeah, I know 74.6 works for my CPU. If you've got a really slow processor, really slow CPU, you might want to set it even lower. If you've got a faster CPU, you might want to set it a bit higher. But you can take into account the problems with your CPU and lag and latency and things. But 75 is if your CPU is 100% perfect speed, like the Flash or something, then you can use that. But just using 75, you see I'm still getting 99% efficiency, so it's not a problem. And that's it. That's vertical solar tracking. I'm just going to hover up here so people can look at it from an aerial view, so they get some idea of where everything should be placed. I mean, you can place these anywhere. You just need to connect up all the holes, basically. The daylight sensor could be anywhere. It has to be on the same circuit. Oops. And as usual, I actually love to put like a little battery, just a small battery, a medium-sized battery between this and the thing, because I don't really trust this thing to last the entire night. particularly if you're like on a cold planet like Europa, or you're drawing a lot of power into lots of different batteries. On my Vulcan setup, I'm not going to give away too much about what's happening because this is being released before the Vulcan thing. But as you can see, I've got solar tracking with all these things. I put the chips on the wall. I nearly always do that. I don't like putting them on the ground. It takes up space. And I've got just this little battery here, which is connected to the power. And it's just good backup. You don't want your power on your tracking to fail, because then you don't get any power coming in. Okay, everyone. I hope you all followed that. It's a tricky one to understand, but once you get your head around it, it's pretty great, and it opens the doors to maybe tinkering with this system and doing some other cool things with it. The other thing you need to know about the horizontal tracking is the way that I've got it placed right now. These things do a complete 360 right during sunset. If you have these reversed, if the power and data were the other way around, you would want to have this thing pointing the other way. So you'd have the data port, you'd be basically using this one instead, and they would do their 360 at dawn. If you have them the other ways, it depends on which way you turn them, so that you've got data on one side and power on the other. They'll do a 360 either in the middle of the day, which is really bad, or middle of the night, which is perfect. You won't lose any power at all. So just letting you know about that 360 maneuver. It doesn't, if it happens at dawn or at dusk, it doesn't really affect. It doesn't affect you that much. The front solar panel might lose a little power, but that's about it. Okay, everyone, thanks for watching. I hope someone gained something from that. Um, I hope you followed all my steps along the way, and yeah, good luck with that, everyone. So thanks for watching, and I hope you tune in for more videos later on. Bye for now.